real short on time because this is going to be a big thing. We're going to run through 5 editors, so I hope there's time for questions at the end. If not, we can go to the overflow room, and then we can ask questions there. All right. Hello, everyone. I'm Robin-Yann Storm. I'm here to talk about keeping level designs in zone through level editor design. I'm a level designer in the Netherlands, and over the last 9 years, I've worked with all kinds of editors and engines, both public and proprietary in-house ones. Over the use of these editors, I've grown accustomed to having to do the same thing in many different ways. Some of these ways made it easier to enter the zone, and others made it more difficult to reach the zone. But what is the zone? The flow state, being in a zone, is completely subconscious. You don't choose to get in or out of a flow state. Your brain does. If the editor does not allow for enough complexity, anxiety sets in. And if the editor makes it tedious to perform tasks, boredom sets in. If the editor allows for complex tasks to be performed skillfully, flow is created, and the developer gets into the zone, which means content quality goes up and quality development time goes up. At the end of the day, you may even be surprised at how much you got done. We'll look at how to minimize those flow stoppers by comparing 5 different and widely used editors, and how we can use that information to improve future editors, both for public and in-house use. Now, I'm not talking about how the game design is communicated to the level designer, or how the editor interfaces with the engine. In this talk, I'm specifically talking about the level designer to editor interface, the UX. This is the critical point where a developer can either get in or out of the flow state. And this is also the critical point from having a game on paper to having a game in the engine. This is where all the creativity lets loose and gets put into a shape that the customer can play. As such, it is a very important step, yet it's often overlooked or sometimes disregarded. Now, the editors we'll be looking at today are Hammer, Unreal Engine 4, Unity, the Skyrim Creation Kit, and 3ds Max. Now, these editors are all widely different, used for a huge variety of games and genres, and all are used by companies to make awesome levels with, which was why we'll be looking at all of them and showcasing their solutions to the same problems level designers face everywhere. All of them also allow for customization to improve their toolset. But for today, we're only going to look at the base editors with no custom plugins, otherwise we'd be here next week still. And although we cannot publicly look at first-party proprietary tools, we can recognize similarities in these public editors that we can apply to our in-house tools. So we're going to look at these specific level design necessities: navigating the editor, creating geometry, snapping, editing geometry, terrain, texturing, lighting, importing assets, placing assets, and playtesting. We're not going to do every single bit for every single engine, as time is limited, so we're sticking to the most important parts of learning about the UX. We will not be discussing scripting, I/O visual scripting, shader editing, nav editing, optimization, and quest and speech trees. There's also more stuff. These are all very important, and these editors carry both good and bad examples of them, and it's really interesting, but there isn't enough time in an hour. If you think I missed something for a specific editor, or you would like to discuss these features anyway, cool, then just come talk to me after the presentation. Lastly, before we go into the meat of the talk, I've noticed there are jargon and terminology differences around the world for developers. Some say engine and mean editor, and some say level designer and also mean environment artist, or a combination of both. Hopefully, with the visuals during this presentation, it'll be clear what's being talked about. If not, please come talk to me after a talk or email me. My email is here and also at the end of the presentation. Okay, so let's start with navigation. So we need to be able to get where we need to be fast and quickly see any part of the level from any angle. Sounds simple, but how do these editors facilitate this? Let's look at Hammer. So there are 4 windows, 1 3D and 3 2D from the top, front, and side. This means that at all times we have a good idea of what the layout of the level is. And we can zoom in and out of every window, so we can quickly see any part of the level we specifically want to understand better. And we can fly around freely, look in any direction we may like. This allows the level designer to stay in the flow and pick and choose what they need to see very fast. And we can make new windows as well, although they do not dock, so it takes a bit of handling if there are many windows. This can take us out of the zone, as instead of seeing something quickly, we may have to find and align the window first. Hammer also has a really neat system called cordon. With it, you can make a box, and anything inside that box is rendered. Anything outside of the box is not. You can resize that box and create more boxes if you like, to only let one part of the level appear. This makes it quick to navigate through a set part of the level. This keeps the level designer in the zone, especially once levels have gotten very large and very complex at the end of the development cycle. Also, you can run the level with only the visible entities running, so tracking down bugs becomes visual as well, again, increasing flow and making it quick and visual. Let's take a look at Unreal. Again, we have 4 windows, 1 3D and 3 2D, although this time they all zoom in at the same time. This is a tiny detail, but it can affect flow, as we may want to see one part of the level from afar and another up close. With this system, we're forced to zoom everywhere. And we can fly around freely and look in any direction at any time. So this makes it quick for the level designer to see what they need to see. And we can dock the windows, so we don't clutter up the monitor with loose windows. This makes it more likely for flow to happen, as we don't clutter up the monitor or have to search for that right window, which binds the other one, which other one, we're going to be alt-tabbing. This is nice and fast. Let's take a look at Unity. Again, we have 4 windows, one 3D and 3 2D. So we can see any part of the level quickly. We can also create new windows if we'd like, and we can fly around freely and look in any direction at any time. We got a flying camera. This makes sure we can see any level quickly at both the macro and micro level. And we can dock the windows again, so into any configuration. We can also have one 3D view and no 2D views if we'd like to. We also don't, again, clutter up the monitor. Let's take a look at Creation Kit. Okay, so there's only one window, and we cannot create any new ones. This makes it more time and mind-consuming to get a fuller idea of the level. And the window also does not dock, so we sort of have to be careful to align it right. And if we have many menus around, we also have to juggle them. And we cannot fly around freely. We have to rotate around a selected object. So we have to change objects and then rotate around them. This system is very fast when using wide open areas and getting a quick overlook over a full area. But this does mean that going through a small indoor section, such as this, requires some fiddling, as we have to find the right object to rotate around, and depending on where we are. So first person is how the player looks at the level in this case. The orbital camera might be fast for looking around objects, but the player won't look at the level in that way. So the workflow the orbital camera creates is one of which many player-centric developments will be missed. That can become a massive development issue caused by a seemingly tiny UX issue. Let's take a look at 3ds Max. 3ds Max, again, has 4 windows. We can zoom in and out, etc. And it has the same orbital camera that we just saw in the Creation Kit. So we can take a quick look around, but it also has the free flying camera if you need to look at a smaller select part of the level. So we can do both. We can do one singular object, and we can fly around and look at a huge level. So what do we learn from looking at this? Well, multi-windows make it possible to see more of the level at a glance. With them, we can quickly find any part of the level and always have an overview. Multiple windows help us stay in the zone. And docking windows can personalize the workspace and increase speed. Loose windows can make you lose focus and having to search for them, which can make for a messy view, which takes us out of the zone. And a free flying camera works in all cases. And while an orbital camera can also work, it requires more actions in indoor spaces. Having both can speed up work here. Also, if you're making a first-person game, it helps facilitate player-centric design. And the hammer coordinate system increases visibility and speed in especially large and complex levels. Navigating through a large and complex level becomes much faster, making sure the focus is on what is important instead of having to deal with the complexity created over a long development time. Now, mind you, none of these particular things are necessarily engine-related. Any editor is able to have any kind of camera system or a system where you draw a box and anything outside that box isn't rendered. So that's not engine-related. Any editor's possibility of these features if the time they save outweighs the time spent creating them. Now, of course, navigation is also tied to UI. So let's grab a specific example. The Creation Kit is made for RPGs, which means we have a huge amount of variables, text, and assets to tweak. This means going through many different menus. And to save what is in a menu, we have to click OK. Otherwise, we'll lose all the work we just did in that menu. OK, so let's take a look at some of the menus in the Creation Kit and where those buttons are. OK, in the Quest menu, it's down and to the right. It's the same location as with most windows on PC. So the level designer is used to it, and it will not interrupt their flow. Let's take a look at another menu. It's down and to the left. OK, it's not terrible yet, so once we're used to working on one menu, we have to adapt to the other, which can take us out of the zone. One more menu. So why is the OK button suddenly all the way up there? 1, it can take a level design out of the zone, and 2, they might click at the X, which is right next to it. If they did 20 minutes of work, they might lose all of it, and a seemingly tiny UX issue can cause this. Now, of course, the Creation Kit is not the only one that does this, though. There's many editors that do these kinds of things. And sure, they're technically usable, but do they facilitate creativity? Sometimes these issues creep up over time due to reasons such as, this is the way we've always done it, or it's not necessary to spend time improving it, just deal with it. But if a developer continually has trouble with an editor or tool, it's not their fault. It's the fault of whoever designed the editor. Think of it, like when a player cannot find to go in a level, do we blame the player or the level designer? So why wouldn't we not blame the tool designer if a user continually makes mistakes with the tool? Now, this book, of course, is a must-read, and most people know that already. But there's also so much wisdom in here for tool designers. Please read it in your own time if you would like to improve your own tools and editors. Let's take a look at creating basic geometry. So we need to be able to quickly place and size basic geometry and to replace large sections of the map quickly and accurately. Because building something is only 30% of development time. Iterating and reworking is the other 70% of development time. So let's take a look at how Hammer tackles this problem. We can select a primitive to place, such as a box, a cylinder, etc., and then we simply click and drag, and we have an outline of the brush that we can place anywhere. Notice how, due to the 4 windows, we can quickly and precisely place the brush exactly where we want to. We don't have to find a pivot, we don't have to look around in the 3D view, we simply click and drag where we want it to be. This keeps us in the flow of work. And we then just press enter to make it appear. We can change the size by grabbing one of the handles and just dragging. We instantly see the measurements on each side in each 2D view, so we know exactly what the sizes are and any time we select a brush. So if we know a player walks at 15 units per second, or an asset was made for 512 units, we can quickly size up the map for both the player and for the environment artists, also saving them time. Let's take a look at Unreal. In Unreal 4, we can click and drag to place a brush of a basic primitive. However, we cannot see the measurements right away. We have to sort of click and drag for each side of the measurements. This adds a step for every single brush we want to place, and for which we want to check the size depending on the player and the environment artist. So tiny things such as this is now creating this butterfly effect. However, in the bottom right, we can also see the measurements and edit them to change the brush size. And to move the brush, we have to specifically click on the pivot. Compare this to Hammer, where we can just click on the brush, any part of the brush. And with this one, we have to find like one of the 3 slivers and click one of those. Again, tiny thing, but it can save some time. Let's take a look at Unity. So we can place different primitives. However, we do not know any of the measurements, as we're only given the scale of the object. Again, this can cause a geometry or art bottleneck that might bite us in the ass later, weeks or even months from after placing this basic geometry. Now, using the Rect tool, we have features slightly similar to Hammer, but it's almost unusable because none of this can be snapped, though the scale numbers do change. So we can place things quickly, but not accurately. Replacing entire sections of a level would become very messy without snapped geometry and accurate measurements. Now, if we were to build an entire level based on these geometry tools, it would be building like a mansion without a proper foundation. It might seem okay now, but the entire place will come crashing down if the Earth so much as shifts a centimeter. Let's take a look at 3ds Max. Now, there's a large amount of primitives we can choose from here. This makes it slightly more flowy for the levels to be less of just boxes and hallways, as we have other shapes to choose from. And the primitives also can be easily changed after placement. We can click and drag to change these variables, keeping the level designer in the flow by allowing them to quickly do a complex task. However, again, we do not see specific measurements on each side, only the height and the radius. Now, we can check for the measurements, though, by going into a separate menu and clicking 2 points. However, where's the measurement now? Take a guess. It's all the way down here. Again, it's a tiny thing, but if we continually have to look up and down the mother, it's not going to promote flow in our brains. It's going to promote annoyance, which will not improve the quality of our levels. So, what did we learn here? Hammer's system of quick placement, basic shaping, and visual measurements is very, very fast. There are no menus necessary, as everything happens where the developer is looking and pointing their mouse. This makes it easier for the level designer to get into the flow than having to use menus. It also enables the developer to iterate extremely rapidly. If a level at the end of the development cycle needs adjustments, then we can do so in seconds and minutes instead of weeks and months. While Unreal also uses BSP, the system is slightly slower overall when placing basic geometry due to requiring a menu and typing to perfectly size up a brush. And Unity sadly has next to no use as a level editor. There are plenty of editor plugins, though, that you can buy, but we're just looking at the out-of-the-box functionality today. And 3ds Max has a large amount of basic geometry to choose from, so a level might not only be made out of boxes. They're also edited through a menu, but in that case it makes sense as they can be quite complex. However, at this point, if you're an Unreal developer, you might be thinking, that's great that you have those opinions, but I'm faster making things in Unreal than you are making things in Hammer. And you might be right. So instead, let's grab some facts. How many clicks, drags, typing, and button presses does it take to create a 512 by 512 by 512 brush in Hammer versus in Unreal? Okay, so in Hammer you would click twice, drag twice, and press a button once. In Unreal you need to click twice, drag once, type 3 times, and press a button twice. Now that might not seem like a big difference, but that's only one brush. Making a basic level can take thousands of brushes, and that's only one level. These extra moments of typing really add up on a project, and that takes months to even years. For 10,000 brushes, the difference becomes between 50,000 actions and 80,000 actions. That's a 30,000 action difference, almost half the time. And that's almost 1/3 of the time saved just because the UX of one editor requires fewer actions than the other. It's not the engine, it's not the user, it's just the UX that causes this time loss. Over development cycle, this is huge. And sure, you might say Hammer is ancient, but this is a tool from 1998. And it still works that fast. I mean, people are making businesses out of providing similar tools for Unity and Unreal Engine 4 developers. It's not about CSG or BSP, it's about how you create geometry. And it's just how about the UX of creating that geometry. So yes, if you look at the time difference in different UX actions, Hammer is faster in creating basic geometry levels. But that's just basic geometry. What about complex geometry? It's a different story. So we want to place and edit complex geometry very quickly. So we have a set of complex geometry we can choose from. This time we choose an arch. We click and drag out a shape, and a menu pops up in which we can change the properties of the arch. And after we press OK, we can scale it and skew it, but we cannot change any of those properties anymore that we saw in the menu. Changing a number down here only applies to new arches, not old ones. And the exact same thing goes for cylinders. We place one, but after this it's set. Changing the number of sides does not do anything, apart from when we place a new one. We can edit it, but that takes considerable manual time, so we cannot quickly and accurately replace large complex sections of the map. So this makes it more difficult to get into the flow when it comes to complex geometry in Hammer. So this could lead to level designers creating only boxes and hallways, because that's the flow of their creation, and that's what they can, that allows them what to do in the production time available. Let's take a look at Unreal. In Unreal, we should show how to place a curved stair. We place it, and then in the menu we have many different options. The inner radius, the angle of the curve, the step height, even the number of stairs. Like, as you can tell, this is full of flow. It's visual, and it allows the level designer to do a complex task very quickly. A level designer will not shy out to make a section with a curved stair. So if after playtesting we want to quickly change a complex piece of geometry, we can do so when it comes to these specific primitives. Unreal also has a subtractive brush system. For example, when we create a sphere, place it inside a brush and then make it subtract. We've then created a hole. So if after playtesting we want to change a large section of indoor space, instead of having to move the 6 sides of a room, we've only placed the one brush that makes up the room. So we don't have to create this whole different thing. So what did we learn here? Well, having a huge variety of primitives makes sure that even complex geometry will be flow viable. And both Unreal and 3ds Max allow for these complex presets to change with numerical values, which promotes flow even with complex levels and geometry. And both also immediately and visually show these changes in the editor views. There's no need to replace entire sections by hand like we would have to do in Hammer. So instead of being afraid we might have to cut levels or stick with old content due to production and time being low, we can just create what we like with high quality. Time can be spent in the zone creating what is both good quality for the player and good quality for the developer. A good thing here is to remember this. Interesting design comes from iteration and trying things out. If the editor does not facilitate this, then the design of the game will stagnate. We do not think of an awesome design and then make it and publish it. No, we think of something cool, we iterate it, and we find things that we never even knew were awesome, and then we use those for great features. So allow the level designer to iterate and explore in the editor, and the design of the game will flourish with it. And if you want to know more about this, I recommend looking at this talk from GDC 2014 by Chris McKenty from Ubisoft. In it, he explains how the amazing editor they made called UbiArt used for Rayman can make it possible for a single level designer to build an entire level and a boss with mechanics and playtest it just through the editor. Just one level design. I mean, think of how many iteration cycles can be sped up solely by improving the editor UX. Let's take a look at snapping tools. These are very important for speed and flow to quickly connect everything and make sure the level designer or artist can create art for the right size so no void or holes are seen by the geometry by the player. Okay, so we want to snap anything to anywhere. Sounds simple. How do these editors do that? When we move a brush around in Hammer, it automatically snaps to the grid. So we never have to worry about anything being off-grid ever, unless we specifically tell it to be. This makes it easier for the level designer to focus on the level and get into the zone, as they don't have to worry and double check all the time. And we can quickly change the grid size with hotkeys, and we instantly see what the right size is. Again, the 4 windows help here, as we can see in any direction where we are in the level and what we're snapping to. Let's take a look at Unity. In Unity, we have to go into a separate menu to change snaps. We don't have any hotkeys to change the grid. This is a huge deal, as we know our flow may be continually interrupted to find the right size to work with. And to snap, we also have to hold down a key on the keyboard, specifically, which can be a physically cumbersome task if we're doing this over long sessions. Though we also have vertex snap capability. In case we're using modular assets, this is really fast. Let's take a look at the creation kit. In the creation kit, we also have snap to grid, but the grid is invisible. Like, I'm changing the grid here, but you don't really notice unless I jiggle something around. So we don't get instant visual feedback. And if we want to fit something, we can do that through vertex snapping, or, even better, we can select a reference to snap to. So as long as the assets themselves abide measurement rules, we can use this to snap what we want, even on really weird angles. So we click on this, click on this, click on the thing that we want to snap it to. And now it's on the same kind of grid level as that other model is. So we don't have 4 windows, so we kind of still have to look around and see where it is, but boom, there it is, it fits. So even if something on a really weird angle, we can make complex levels, really cool gameplay, and it still is easy to edit later. Let's take a look at 3ds Max. To show the snap settings in Max, we go into this menu, and we have a huge variety of snaps available. And we can also change all these measurements. There are shortcuts to change these settings. It can be customized as well. If you want to snap anything, you can do it with 3ds Max. Okay. So what do we learn from this? Like, a large variety of snaps is nice, as it saves time and to create the possibility for complex geometry and levels that is still easy to edit. It maintains flow while allowing for a wide variety of gameplay possibilities. And vertex snaps are especially useful for modular games. Off-grid snaps again create the possibility for complex geometry. So you don't have to worry about a particular complex section of a level becoming too complex to change later. It maintains flow over the entire project length and helps with every part of level placement. Geometry, lights, assets, anything. And of course, fast snap changes with hotkeys are nice, as having to go through menus costs valuable time and cognitive effort. But let's take a look at the differences these hotkeys just can make. How to change snaps and what the current size is for all 5 editors I'm talking about. I mean, that's pretty crazy. That's not to say hotkeys are easy to do, though. They have their own problems as well. So let's say, for example, we have a new editor feature and it's called Geometry Lock. It's been decided to use Control-L for this as it uses the same letter. Okay, sounds good. Let's do this. So we have to use this feature a lot. Let's say like once every 2 minutes. I mean, ouch. I mean, my hand is like stretching and struggling to reach that position. It's just not nice to use. Let's take a look at another one, Control-S. We use this about 50 times an hour, and we use it all the time. It feels nice. It doesn't hurt my hand. I can keep on doing it all day. Let's take a look at Shift-M. Okay, it's a bit further. It's still possible, though, and not as painful as Control-L. Let's take a look at Control-Alt-T. You can look at my tendons just whitening out. I mean, if this is an often used shortcut, even just 2 times an hour, at the end of the work week, I will need physical therapy to make sure that my hand isn't hurting every single day. And that's just through a shortcut. But I'm not saying there should be standards for every single shortcut, because then we're going to run into this. There are 40 competing standards. Hey, we're going to make the one ultimate standard, and now there's 15 competing standards. Standards are sadly not realistic, but hopefully we can work towards making these shortcuts less physically painful. I mean, all these shortcuts I just showed you are from actual editors that I have been using. Anyway, let's move on to the next feature. Editing geometry. We've placed it, maybe we changed some values, but now we want to really put it into shape. Okay, so level designers need to be able to quickly edit geometry. Cool, let's take a look. So we can use the vertex tool to move vertices around and instantly see the result. This keeps the level designer in the flow, focusing on making the level awesome. And we can also place a bounding box for more complex geometry that will have a lot of vertices. So only the vertices inside that box are selected. So if we make really complex geometry, we can still easily edit it later without fear of it becoming a mess that is hard to edit. With the clipping tool, we can click and drag to create a clip that cuts a brush into any shape we like. And we see the cut in both the 2D and the 3D views. And then we press Enter to cut, and the red side is removed as shown in the 2D view. We can change which side is cut by pressing the tool icon, so we can cut a different size or only cut and not remove any section. Everything is very visual. We always see exactly what's going on, and we never have to double check. We can then also individually move each section if we want to. Let's take a look at Unreal. And on Unreal, we also have a vertex tool, so we can click and drag to select which vertices we want and then drag them around, and we also instantly see the result. However, we have no idea what the measurements have become. None of the measurements in the if menu down there have changed. And also, we cannot shape the brush using these vertices, because if we try to do this perfectly every time, the pivot point is still going to be at the old location. This requires us to go through a drop-down menu to set the pivot point and save the pivot point every time we do a vertex edit on a brush. So over thousands of brushes, this will take us right out of the zone, because we have to focus on making those pivots fit perfectly. Otherwise, maybe I end up in a situation later where we want to move a brush, and the pivot may be at the other end of the map after a long time and many iterations. So over time, this can cost us a lot of time and a lot of flow for many different level designers. Now, the clipping tool for Unreal requires us to point somewhere, press spacebar, and then point somewhere else and tap spacebar again. We cannot see what we clipped in the 3D view, though. And if we want to redo the clip, we have to redo the entire pointing and spacebar process, as we cannot move the handles individually. And we have to try to gauge what will be clipped, because it was not... and then try to clip. It will tell us to refocus on the window, but there's only one clip, so why would it need to refocus the window? There's only one that we could use. And when we do clip, this also doesn't seem to be working entirely correct in this case. I mean, all in all, it's just a mess of key presses and mouse clicks that's not visual at all, and as it may require some time-intensive redos to edit geometry looking right later. Let's take a look at 3ds Max. Now in 3ds Max, we have a very unique system of editing. We can add triangles, add an edit poly modifier, and then individually move vertices, faces, and edges around. We can also add a huge amount of different modifiers. In this case, we're using bend. And so we bend something really quickly, and then we go into the stack and we want to change the geometry. So for this case, for example, we add an edge loop, and then we edit those edges to be like a different kind of shape. We want to make something sci-fi, for example. Then we go back up to bend modifier, and boom, there it is. Quickly, visually, it just kind of works. And there are many modifiers for all kinds of different cases, like terrain, water, rocks, spaceship hulls. Now you may be thinking, well, that's a bit unfair to compare a geometry editing tool to level editors. Of course, 3ds Max is faster and allows for more complexity. That's its prime purpose. But I'm not directly comparing them in their quality. I'm only showing the different solutions out there for the same problems. All these editors have made amazing levels for video games, and they're all being used for level editing. What can we learn from this? Well, in this case, modifiers are insane. Okay, they allow you to edit and shape any kind of geometry in any shape you may need, and quickly too. And geometry editing tools such as vertex cutting, extruding, etc. only clear visuals, as without them we may have to redo work as we cannot see what needs to be done, which can take a level designer out of the zone, and we have to redo work. Now of course this is a tiny part of geometry editing tools that I've just shown. There's much more out there. For even more complex geometry, we can also learn from other fields. For example, this is a piece of software called FormZ, used a lot by architects. In it, you can use a spline to place a complex wall very fast and edit it fast too. I mean, think of the gameplay possibilities when a level designer can easily place a way more wide variety of geometry. Both the possible content complexity and the direct content quality go up, because the developer can do what they wish with their flow maintained. But you may think, yeah, but we can already do that in our tool, our editor right here. It just takes more clicks than these editors, but we can do it. Just because the pipeline is functional doesn't mean the pipeline is done. UX and UI matters for games as much as UX and UI matters for editors. You might think, well, it works so it's done, but as you've seen in this presentation, small issues can have large production impacts. Just because you can do something in a tool doesn't mean the tools are finished and we can cease development on them. A really great example for games about this is The Witcher 3. The button to loot and the button to extinguish are the same. Which means if a player opens a chest and a candle is nearby, they might extinguish the candle instead of looting. Then they try to open the chest again and they might relight the candle again. Now you've done two actions and you still haven't done what you want to do. This was such a big issue for players that was actually patched very soon, which is awesome for CD Projekt Red. Why is that awesome? Because this wasn't a game-critical bug. You could play through the entire game from start to finish completely. It didn't leave you stuck or crash the game, and yet it was discussed on multiple articles. Hundreds of threads were made about this, and it was quickly patched. That's for a 45-hour game. We work with editors for multiple years, and yet if we run into an UX issue, we tell ourselves, well, we'll just deal with it. UX issues like these can be very detrimental to the work as developers. So don't stop developing a tool when it functions. Stop developing a tool when it allows creativity to flourish. Just as much as a signage issue, a very on-the-nose example of this is this. This is a level editor where you cannot use the mouse to navigate the camera. The menu on the left, with the angles and coordinates, you have to press those buttons to move the camera around. Somewhere out there, a person said, you can build a level with this. There's no need to spend programming time on extra features. And they're technically right, but you would develop this tool further or make a different one. This is a very on-the-nose example, of course, but these things are happening everywhere, especially with in-house tools. Let's take a look at terrain. So, quickly edit terrain in any shape you might need. Cool. So in Hammer, we call it displacements in this case. We select the face of a brush and then we create the displacements of it. The non-displacement side of the brush are then no longer in use, but we can still make them appear. We can then quickly still place and copy the displacements as they're handled just like regular brushes. So our tool use, our flow stays the same. We can then edit the terrain by pushing and pulling. And if a gap appears and the brush is aligned, we can quickly sew a section so that no holes appear. And we can keep on editing, but if we then want to add more faces to the displacement, we make them appear, select them, and we can convert them to displacements. And again, there's a hole again, so we select them and we sew the gap. We can also still edit the brush like we did earlier with the vertex tool. So we can create overhanging cliffs or even caves with this kind of terrain system. Let's take a look at Unreal. Now Unreal has many options for its terrain. And once we've placed it, we have a huge variety of tools to work with. So many, in fact, that we don't have time to cover them all. We can generate roads, apply height maps, use splines, copy sections of height and paste them over. For large swaths of terrain, this is very useful. However, we do not have as minute control as we did in Hammer. We cannot create cliffs or caves, and we cannot sew together terrain like we would like to link. So we have to cover that up with models along the lines, which might not look as pretty. Let's take a look at Unity. For Unity terrain, we cannot see the size, and we do have a selection of brushes to choose from, though. So if you're specifically looking to draw like a star-shaped mountain fast, this really helps. However, again, we do not have as much minute control, and we cannot create cliffs or caves. So what did we learn here? Well, this is not an easy one to find a one-way takeaway for. There is a large difference in small terrain versus large terrain tools. For example, Hammer allows for any kind of shape of terrain and has minute control, but it's time-consuming to create large terrain, and it does not allow for height maps or direct texture maps, as we have to draw everything on, though it is also engine-related. And while Unreal also allows for quick height and texture maps, but cliffs and caves cannot be made. It seems to be a trade-off between complexity and speed, with a system that would have both be best, but I haven't seen anything like that yet. I'm still wondering why sometime in the past we decided we didn't need cliffs or caves anymore, and settled with using models to cover them all up. I mean, it just increased the workload for artists instead of letting a designer to deal with the problem. So look at your game, look at what it needs, and make sure that what you need is what the editor allows the level designer to do, automatically if necessary, so they can stay in their flow. If you want to hear more about this, take a look at the Halo 2 anniversary talk from GDC 2015 by Michael Pavlovich. As you also see here on the slide, avoid rocket-powered shit shoveling. Keep skilled workers doing skilled work. Avoid menial process task fatigue. Because again, remember this graph, these couple of extra actions really add something. Oops. And remember this graph. Fatigue happens if we reach one of the top or bottom sections. We need to stay in the middle. And by fatigue, I mean this kind of thing. Physical energy, mental energy, and psychological energy. If physical energy runs out, we're going to be uncomfortable and we want to lie down. If mental energy runs out, because we have to deal with so many things at the same time, we lose creativity. And if we remove some of these mental hoops to jump through, it can save fatigue over long development times. And psychological energy. If we ever continually have to, for example, start and restart the editor every time to check something for small changes, any person will slowly start to lose their mind and they cannot work. They're physically and mentally fine, but they cannot work anymore. Small things that drain this quickly are like your Wi-Fi constantly dropping out, like some of you are probably experiencing here at GDC. It's very annoying, and sure, you can keep on working, but it's annoyance that slowly seeps into your brain over time until you cannot focus on it anymore and your creativity is lost. I mean, is it worth people getting sick and staying home over these kinds of things if they can be fixed? Because again, just because the pipeline's functional doesn't mean the pipeline's done. All right, let's look at the next thing, texturing. So we want to find available textures quickly and texture basic and complex geometry quickly. And retexture large sectors of the map quickly and accurately for when we iterate. So let's look at Hammer. We can look in a texture browser and we can use shortcuts to search through the names of textures. For example, we type in wall and we just scroll through and we can try and find something. This is not really really nice. So what if, for example, we want to look for a green wall? So we type in wall green. And there's no results. Okay, maybe what if we type green wall? Nope, also no results. What about like concrete wall? Does that work? Okay, yeah, we see concrete walls. Oh, cool. So we can take a look through them, try to just look around, and hey, there's a green wall. But the name is completely different to what we expect. So we have to remember every single name of these textures because we're going to be busy more with our minds remembering names or scrolling through these textures than actually focusing on the level. I mean, there's ways to create tags for these textures, but you would have to manually enter them for each material in the files, which requires to get out of the editor and out of the zone. Now with the texture selected, we simply right-click on faces to put the texture on them. So if a face next to it is selected, it also retains the UV, and it tiles very smoothly and quickly. I mean, even on complex geometry such as cylinders or arches. There's no seams anywhere, and there's no stretching. Ah, beautiful. All right, Unreal. Okay, so this texture searching system in Unreal also has the same name convention issue. You would have to remember every single name to make sure we find the correct kind of texture. What is a lot faster, though, is the collection system. We can create named collections and then drag assets in there. So if we click on the collections, we see everything that is in there. The same asset can be in multiple collections, so it makes it a bit faster to find the correct assets we need. If this system is well equipped by developers, it can really speed up having to find models, as all the keywords are visually laid out and set, regardless of the model names. Although, over huge games, you again run into the problem of having to scroll through a list of collections. To apply textures, we can click and drag, or we can alt-click. However, to UV the faces, we would have to do so manually. So, for example, looking at this box, there's a visible seam. Okay, you want to get rid of this seam, but all that we can do is change these numbers to sort of really try a lot just to get it in shape, which takes a lot of time. So especially on complex geometry such as this curved stair, it becomes a very time-consuming process to texture it and make it look nice and tiled. We can easily see the seams. Let's take a look at 3ds Max. Now, 3ds Max, we have a system with a list of icons, and we create materials per scene. We can then apply the textures by clicking a button. We can then either decide to UV, which means manually setting everything right, like we saw in Unreal. We just push buttons around and numbers and hope it works. Or we can decide to unwrap, which is a very time-consuming process. Not on this cube specifically, but if we have complex geometry, it's going to take a while. So yes, we can UV it perfectly, but it will take a long time to do so. So what do you learn here? Well, when it comes to texturing, Hammer comes out on top when it comes to applying, even on very complex geometry with seamless transfers from face to face being achieved by clicking instead of fiddling with menus, though the menu is still there in case it is necessary to work with. But on Unreal 4 you have faster systems for finding specific textures, especially on larger games and databases. As with Hammer, we would have to either make very large file names to include all the specifics or remember every single name available. Much like what we saw earlier with menus, if we make it needlessly complicated to find something, we might never use it even though it might be very useful. The same goes for textures. We need to make sure we can place them fast and edit them fast while staying in the zone. This is extremely worthwhile. If someone tells me to build the Mona Lisa in Excel and I object, explaining it takes a tremendous amount of time to texture it and it's very slow to edit later on, the reply I get should not be like, oh, just keep on using it like the rest of us, you will get used to it, or even worse, a good craftsman never blames his tools. Just because it's possible for someone to build the Mona Lisa in Excel doesn't mean the next big game, AAA or indie, doesn't matter, will make its textures in Excel. So, lighting, what are we looking for here? If we want to place lights quickly, change the settings quickly, and quickly see what they look like. Sadly, this is also very much related to the engine, so not everything here is purely UX related. Let's take a look at Hammer. So we can place basic lights as a directional, spot, point, a sun, etc. And we can then edit the color and intensity of that light. But we don't see what the actual light looks like. We can change the fall off of the light and get an idea of how far it goes, but we still do not see what the light looks like. If we place a spot, we get a visibility column that showcases where the light will go and what color it is. But we again do not actually see what the light will look like. To see what it looks like, we'd have to compile the map. And on a small map, this is nice and fast, but for later stages of development, we would need either a beast of a machine or a long time to see even small edits. Let's take a look at Unreal. In Unreal, we again have a basic choice of basic lights, and when we place them, we instantly get an indication of what it will look like in-game. You can also toggle the view window to a game view, making it so you can instantly see what's in a scene without all the editor icons. We can also bake and compile this for a final view if we want to, but we get a good idea of what the light looks like right away. For spots, we also still have the cone, so we have a better idea, but any movement and color is also instantly shown. Let's take a look at the creation kit. On the left, we have a huge list of lights we can choose from. These range from spots, glows, fire torches, campfires, bonfires, anything. A large variety of preset choices are available. And we can add new ones to this or edit an existing one. There's a nice instancing system here too, where if we change the light in this big list and any of those lights are in a scene somewhere else, they also all change automatically, which can save time over huge projects, like Skyrim is. If we open up a preview window though, we cannot see what the light looks like because there's nothing to bounce off of. So we have to click and drag it into the scene to see what it looks like, which is a bit time and action intensive. We also have instant light visibility, which we also toggle on and off. And to change the light settings, we can also click on the light to go into a menu. But that menu has tabs. It has many, many, many tabs. So we have to find the right one, and then we can edit the specific variable we want to. As you can probably guess, that's pretty slow, and it takes us out of the flow of work. There are a lot of options, that's great, but going through them by having to click many times is going to take us out of the zone. Now you might say, oh, so just drag to make the window bigger, and the tabs will be more widespread across the screen. But you can't. This window menu cannot be made bigger or smaller. It's very, very time intensive, and not engine related. This is just a UI issue. Let's take a look at 3ds Max. In 3ds Max, again, we have a basic choice of lights, a visible cone, and instant lighting visibility. We can quickly and accurately change the light settings. It seems to be very WYSIWYG, but of course, in 3ds Max, we're going to have to port it to our engine, so we don't really know if it's one-to-one to in-game lighting. Okay, so what do we learn here? Well, in this case, Unreal 4 is pretty damn good, and Unity is very similar to that, where we both have live lighting. And the Scrying Creation Kit has a lot more options, which is nice, but to get through them or just to access the basic ones requires a lot of time and clicking. Having a huge preset list to choose from can save time, especially over large projects. And visible guidelines help a lot, and of course, live lighting is the absolute best time saver ever. Being able to compile for better results later is nice, but seeing what you're doing instantly visually helps a lot. However, this is all very engine dependent as well. And so having a lot of choice is great, but make sure the menus do not take up too much time and effort to use. Yes, time and effort for menu UX. Can menus really be that detrimental? A really great real-life example of this is what Adam Savage, the ex-Mythbuster, did with his workshop. Adam Savage removed as many drawers from his workshop so that everything has as much instant access as possible. By looking across the workshop, you can see where a particular tool is, grab it immediately when walking towards it. Everything that's in a drawer will slowly disappear and not be used anymore. There are so many things that your mind can think of if you just see it, if it's in your direct view. That's sadly just a human problem. So the same goes for menus and editors. If there's a menu, in a drop-down menu, it will take 3 clicks to finally be used. And that's so non-visual that whatever is in that menu will probably never be used anyway. Of course, for complex systems, a menu is good to have, especially when it comes to multiple variable settings. But for simple things, such as changing snaps, it's time-consuming to have to go through a menu every time. There are better ways of doing this. Take, for example, a look at compare the menus and lists and text with the universal UI of WoW. Yes, you can click through the spellbook and read everything if you want to, but in-game, you can just hover over, just click icons all the time. There's so many abilities, but there's a universal icon structure that everyone understands. I mean, there are 10 million people playing this, and they understand the icons, and it's nice for them to use. So having a giant amount of icons on screen isn't a bad thing. It's a lot better than having all the icons and having a screen full of text that you constantly have to read through. And add the ability to put the icons in the position you want them, and suddenly you have devs setting up their workflow the way they want it. There's no menus needed. I mean, again, there's still spellbook if you want to read everything, but everything you need is right there. And that's not the only problem with menus. There's also another. Many of you, especially programmers, already know this comic. There's a common problem where a programmer is disrupted by someone coming into their office and saying one thing while they were really busy with a really complex issue, and it all disappears into a black hole due to the interruption. The same exact thing can happen when a level designer is disrupted by having to search through 5 menus and 3 drop-downs. Just as much as a gameplay or narrative designer is disrupted by having their images in Microsoft Word shift all over the place when making what should be a simple edit. This kind of losing flow, losing that bit of in the zone, can have huge impacts. If the editor has so many menus that need to be accessed all the time, it'll be almost impossible for the brain to reach that zone state. Because if we create that space for time and relaxation, where we can do anything we like and focus on a problem at hand, we generate better solutions. If I'm in flow, thinking of creative and awesome solutions for difficult problems in art, scripting, design, anything, then suddenly I need to click through 5 tabs to do that cool thing I thought about, my intention and relaxation is gone. Not because I want it to be, but because I'm a human being that is taken out of flow by clicking 5 tabs. And talking about suffering, by the way, the brightness of the editor also affects the developer. I mean, looking at a monitor 12 hours a day can make your eyes feel painful. Many people already use Flux or similar software to help keeping their eyes from suffering over 60-hour work weeks. This GIF isn't really nice on your eyes, is it? Exactly. Your eyes are constantly focusing and refocusing. It's painful. So instead, dark backgrounds are much easier on the eyes, especially in crunch times and at night. This is a super simple thing that can save the eyes and sanity of your developers. Keeping it dark with the right amount of highlights feels much better on the eyes, or at least having an option to turn on a dark UI for the people that need it can really help here. So let's go to importing assets. What do we need here? Well, quickly get anything into the editor. Cool. Let's take a look at how my hammer does it. So some of you who've used this probably already know how difficult this is. I don't have a video of it, as it would take too long to showcase the full process. In short, if you want to do it in a less painful way than using the first-party tools, which require you to use a command prompt window to search for a script file to compile your model, then you have to use third-party tools found on the internet. And those tools might be updated to the latest version of Max, Photoshop, and Maya, and they might not be. And if something breaks or gives errors, you can only hope someone else on the internet has found a solution, or else you're out of luck. So you have to go through this time-consuming process to get any asset in game. So making modular assets for source and adapting them can make almost impossible for a level designer to get into the zone. In the end, you'll have to close and open about 3 to 4 different pieces of software. And there are mods out there, like award-winning mods for source, that did not include fantastic assets that were already finished, as it was too complicated to get them into the engine. And that's just a shame. Let's take a look at Unreal. We can click the import button and select a model, or we can click and drag a model in. This texture the texture is automatically loaded as well. It's nice, visual, fast. There's also an even faster way where you can directly save from your modeling software into a folder, and Unreal 4 automatically grabs and imports anything in the folder. So yeah, really fast. Unreal 4 also automatically creates a preview icon for the model, which helps for searching with the assets. Let's take a look at Unity. Unity is about the same as Unreal. We can click and drag a model in, although the scale might be a bit off as we don't really know any of the measurements because, again, we're just working with scale. All right, let's take a look at the creation kit. Again, a video of this process would take too long. The process is, again, with third-party tools, so if anything breaks, your Google searching skills would have to be in good shape. And again, the third-party tools may not be usable with the current version of software. I tried to put something in the creation kit with 3ds Max 2016, couldn't do it, had to download an older version to make it happen. Let's take a look at what we learned here. So, of course, Valve and Bethesda may have way better first-party systems in-house that only they use, but sadly we can't look at those and learn from them. So, very obviously, but still worth pointing out, clicking and dragging is very fast. And the directory load system, where any model in the directory is loaded automatically, is also very nice and fast, as it skips even the clicking and dragging. And an automatic import for textures attached to the models is fantastic, as it skips another step where bugs or errors could pop up if it were done manually. And automatic icon creation for searching purposes is awesome. This makes it easier to work with the content once it's imported, especially when we're talking about a large game or mod. And these kinds of problems, if never solved, can really snowball out of proportion. Good and bad UX have huge impacts. I mean, there's pretty crazy differences here. And they can have huge effects over time. And of course, these are kind of the spiral of good UX and spiral of bad UX. Spiral of good UX is okay. We've got creative problem solving, faster development time, which creates quality content, which creates happy developers because they know their content is good or bad, which create more creative problem solving. And there's bad UX. There's one-way problem solving, slower development time, inferior content, which creates unhappy developers because we know when our content's bad, and which creates more one-way problem solving. So there's really a lot of stuff that can happen if we give the power to the level designers to change these things. And by power, I mean the ability to do so within the producing time. How do you grant them this ability? By designing editors with good UX. So don't believe me? Let's grab an example. We want to solve a signposting issue. So we have 2 ways of doing this. Either a level designer changes geometry, imports an asset, changes the lighting, and playtests in editor to see if the new signposting works. Or the programmers have to create a new floating arrow system, The artist had to create a new good-looking arrow for the system, the producer has to find time for these groups to communicate effectively so no time is lost, and QA has to test for the new arrow system. And the only difference between these two solutions is whether the level designer has the editing power to change those things themselves. I mean, the level designer can bring it up to working levels, and then the other developers can make sure that it's shippable quality, which brings down the number of total iterations. If it takes very long to implement a level fix, or it's made difficult or bad with bad editor UI, you'll have no choice but to add quest markers, and when tester feedback says it's difficult to get somewhere, as it's the most production-safe way of handling that feedback. So instead of levels being iterated, new functions are being added to solve these gaps. And this is not due to the editor being dysfunctional, not due to the engine being bad, not due to the developers being bad, but only due to the editor UX being bad. I mean, look at the huge amount of time and effort saved with good editor UX. However, there is a direct correlation between a tool being more revolutionary and the difficulty of getting people behind that process, simply due to the perceived risk. And there are many reasons for this, but the biggest one, of course, being, like we discussed before, the level designer asks, but the producer and programmer have to do. That's not a nice trade. Now, some companies cut out the middleman here. They tend to hire level designers who can also program. However, those individuals may be hard to find or very expensive. So instead, all I can say is that I hope with this presentation, it becomes more clear that level designers do not ask solely for themselves, but also for the sake of the entire game. Because again, they tend to be one of the key links between the game design and the actual product that the user plays. So if you like this talk or its contents, don't shy away from showing it to your entire team or just the programmers or the level designers. Everyone is impacted by these editors and flow. Okay, let's look at placing assets. So we want to quickly place stuff and basically reposition quickly in both the large and small volumes. Okay, let's take a look. So in Hammer, we can select a variety of prop entities, such as dynamic, physics, static, etc. We then place it, and then we have to find a model for it. We have to do this by keywords. So again, we run into the same issues as we did with textures. Either we have to scroll through a big list, or we have to remember all the names. And there might also be a model in there you might not expect. Like if we search for door, we might also find something called an indoor bench. And Hammer does allow for a very quick way to copy and paste. For example, getting a prop to sit perfectly on the ground takes a bit of fiddling if we move it manually. But if we copy it and paste it, it pastes exactly to where we point with the mouse. And the model is perfectly set on the ground. This can save time when it comes to detailing a map or placing many of the same props, as we don't need to grab a movement or type in coordinates. An interesting system Hammer also allows for is instances. We place an instance entity and then you tie a map file to it. The entity then shows what is in that map file. We can then copy and paste multiple of these entities around. And if we then go into the original map file we tied to it, we can make changes to it. Close this, go into the map file. And there we see it, like there's a light and a couple of entities and a brush, piece of geometry. Okay, cool. So if we make changes here, we go back, everything is automatically changes. So if I have a complex light setup, a geometry setup, or like some kind of entity setup, we can easily change all of them in 1 minute. Let's take a look at Unreal. In Unreal, we simply click and drag from the model browser, which is a bit faster. And we can still change the model if we'd like to. Though we have to use the pivot to move the model. And if we copy and paste, we have to continually drag out the next model to the correct position. And we, of course, have the same keyword searching system, though again, the collection system helps here too. Let's take a look at Unity. In Unity, we have a similar system to Unreal, where we click and drag a model into the scene. And to copy and paste, we need to duplicate, click, and drag. Again, we can search through keywords and tags. Let's look at Creation Kit. To find assets in the Creation Kit, we have to go through many different directories to find the correct models to work with, due to the entire geometry being made out of assets. There are no visual icons present, and again, we can search through keywords only. There's a preview window we can make appear, but it shows the assets one after another, also like we saw in Hammer, which is slow when dealing with the large amount of assets available in this case. Although switching out models is quite fast if we need to do so. I mean, simply adding icons here instead of just text can save a huge amount of time, because we can quickly, in one glance, see exactly what we need, instead of having to go through this and sort of just finding that exact right thing that we need. So what do we learn here? Well, icon searching is much faster than text searching, as it provides an at-a-glance overview. And a collection or tagging system is faster than a text system, especially for large asset databases. And positional copying where the user is pointing is a bit faster than dragging or typing coordinates, especially when working with large levels and complex geometry. And instancing or prefabs are very useful in placing many of the same assets or groups of assets. They speed up the iteration process, as less time has to be spent doing the same thing over and over, and everything changes immediately. Inside editors, though, there are also ways of making the process of finding assets even faster. For example, the Team Fortress 2 community started making prop libraries, like a Bajoom Snark did this, which is a level with all the assets of the game in them sorted by kind. Rocks with rocks, pipes with pipes, boxes with boxes, etc. In this way, no matter what the name of the model file is, it is visually immediately apparent what the choices are, and we can simply copy and paste them over. It saves the level designer having to go through text lists one by one. The exact same thing was also released by Valve on the latest operation for Counter-Strike Go. So let's say I want to change this brush with a model. So I go into the zoo that Valve created, and I get an immediate visual overview of all my choices. I don't need to remember any names, and I always know exactly what my choices are, even between high and low poly models. Now this system is slower when the level designer working on the level knows all the assets by name, but especially when bringing on new developers or really large systems, this is way, way better. Like, I can find, having level designers switch between levels, it provides a way of getting acquainted with all the options, and it's like a garden to get inspiration from. I can then find a model, and then I can then just paste it over. If I ever need to change it, I can then do it by name if I'd like to. So I just click on it, paste it, move it there, remove the brush, and I'm done. So let's play a game here called Name That Model, and I want you all to play along. Just yell loudly so I can hear you. Okay, so what is this model called? Any suggestions?
Gates.
Sorry? Gates. It's called a meter. So if you haven't typed in meter, you can't find that model. Okay, let's do this one. What would this be called? Suggestions? Sorry? Fence. It's called a grill. You can see that it sort of makes sense, but you would never type that in to find it. Let's do another one. What's this one called? Bracket. Nice job. It's called a prison bracket. Let's look at this one. What is this one called then? Rail. Lever. It's called a scaffolding building edge support. Okay, final one. What would this be called? Rails? Rails? Yeah, we all think rails? It's called a run straight. Anyway, you get the idea. So finding models based on names is just not good for flow, especially when working with bilingual teams and if you're outsourcing art, because you're just going to have trouble with that. Okay, final thing, playtesting. Okay, so what I want to do, quickly get in and out of the game and playtest stuff. Cool. Okay, how does Hammer do this? Well, first we need to place a spawn point, and then we have to compile the level. And this can take 5 minutes or up to an hour, depending on many different factors. And we also need to remember the location of the spawn point and make sure we move it around if we want to playtest a specific section of the map. Otherwise, we may waste time running through the map to find the right location. Again, one more tiny thing we have to remember. Instead of getting into the zone and thinking, how can I make this level the best it can be, my brain is now focusing on like, okay, so where's that spawn? Because I don't need to forget it, otherwise I'll facepalm myself and I'll lose time. It takes me out of the zone. Okay, let's take a look at Unreal. And Unreal, we have to right-click anywhere and press play here. There's no need to move a spawner around or wait for a game or map to load. We just click and play. There's no need to compile either. I mean, yes, we can if we want to, but there's no requirement to do so. Let's take a look at Unity. Now, press play, and whatever's programmed to be the main camera or player character, or whatever it is you made, will start playing. This is very fast, and there's a very nice pause and frame-by-frame system as well. If anything goes wrong unexpectedly, it's quite simple to pause and then immediately fly around to look up what went wrong, and everything stays put. It is also possible to adapt the scene while paused. For example, you can see I moved the ramp a bit further here and can move it even further here. This pause and edit system makes for extremely fast testing and iteration of changes. Let's take a look at the creation kit. To playtest in the creation kit, a spawn location needs to be moved around to the correct place, and the level needs to be saved, and the game needs to be started with the right content enabled. The player can then spawn into the level using the console. Well, if you then wish to edit the level and tab in to see changes, you can't. You will have to unload and reload the game every time and edit this game, so you have to completely quit it and completely start it up again. This can be very costly in time, especially when it comes to smaller changes and the speed of loading. And 3ds Max, well, you can't. They're probably currently working on something, but right now you can't play anything in 3ds Max. Okay, so having an in-editor check so we don't have to start up the game saves a lot of time, and we can focus on the level instead of having to wait. Otherwise, it's nice if we can keep the game and the editor running at the same time, so we don't have to reload either one in between changes. And clicking a location to play is very nice, as it means we don't have to keep thinking about where the spawn location is or any other entities that are tied to it, and we don't have to move them around. We can focus on the problem at hand. And of course, flying and editing during pause time is incredible. It really speeds up the iteration process, as problems can quickly be found and adapted without having to go through a playtesting pipeline. Though, of course, all these issues are also engine dependent. So it's difficult to implement this, but it may be worth it over large and longer projects, depending on what you're working on. So, those are all the topics we've covered today. I hope this has been useful to you, and I just want to reiterate the most important points. Look at other games for inspiration, and look at other editors for inspiration. This may seem obvious, but as we saw through this presentation, many solutions are already present, and they just haven't been implemented yet in other editors. And interesting design comes from iteration and trying things out. If the editor does not facilitate this, then the design of the game will stagnate. And really tiny issues can have really huge impacts over long projects. And there are many more companies doing these kinds of things already, but they get rarely shared and usually stay in-house under NDA. So if someone does talk about them, just grab it and shake all the information out of them you could possibly have, because it's really, really valuable. And just because a pipeline is functional doesn't mean the pipeline's done. UX UI matters for games as much as it matters for editors. Again, just remember, like a 45-hour game quickly patched, 3-hour-long editor not worked on? Again, like and don't answer someone's cries for help with just keep on using it like the rest of us, or you will get used to it, or a good craftsman never blames his tools. And fatigue happens. It's a real thing, so watch out for this. And that is the fault of whoever designed an editor if a user just consistently does something wrong. And create a space for creativity and flow, being in the zone. It reflects in our work. And remember the spirals of good and bad UX and the butterfly effects that they can cause. And huge amounts of time and effort can be saved just through UX. So in short, saying a good craftsman never blames his tool is detrimental to your game, your developers, and your customers. Should developers be smart enough to know what tools to pick and what to use for which task? Yes. Should developers be smart enough to realize when their tools are holding back the game's potential? Yes. Thank you very much. I would like thank these people for all the help they gave me. And I want to thank these editors for existing. Like, it's awesome that we can all create stuff, also at home from modders. These are the sources that I used. And are there any questions? I think we have 5 minutes left. Is that correct? Yes, cool.
Hey, man. So I think we can all agree that searching a thing for an asset by name is terrible. But do you have any ideas about solving that problem, like tagging systems that don't require people to figure out everything about their asset that some other person might search?
The zoo thing is still like the best thing that I've seen so far. And what I showed in the video was only models in this case, but actually I didn't show another part of the level which Valve also made, which is a texture section. So you have this huge wall of textures with all the shaders on them, and you just look around them and go, hey, that's the kind of red shade I want. And you just right there.
Right,
you don't have to remember tags or names.
For, like Sunset Overdrive, we had over 200,000 assets, and creating the zoo would have taken been a full-time job. So do you know of anything that could automate that?
Yes, well, there is a system which is now really aged, not in use anymore, which was done by Valve also a long time ago, which is what they call an entity sprawl, I think it is. So basically click on a button and it basically spawns every single entity that it has on the entire map, in sections, so you sort of know where everything is. Now, if you've named things moderately good, you can develop a system okay, everything that has the word wood in it goes to this section of the map. Anything that has the word pipe in it goes in this section of the map. I haven't seen anyone else do that yet, though. Yeah, so it's not really a solved issue yet.
All right, thanks.
Any other questions? No? Cool. Well, if you do have any questions later, you can also still grab a stroll waffle or find me in the wrapper room. Thank you very much.